Yeah. I'd like to say hello, and I'd like to welcome and thank everyone for attending securing your Pulsar cluster with Vault. My name is Chris Kellogg. Currently, I'm a software engineer at Splunk. I've been working with Apache Pulsar since 2017, and during that time, I've had numerous opportunities to deploy Pulsar clusters across many different cloud providers as well as many different environments. So today I'd like to go over, why I would use Vault with Pulsar, or why Pulsar and Vault are a good fit. Excuse me. So I'd like to start off with a brief overview of Vault for those of you who don't know about Vault or have never heard of it. Then I'd kind of like to walk you through why Pulsar and Vault are a good fit. I'd also then like to walk you through the security model of Pulsar and what it offers. And then I'll walk through a few slides of how do you create custom plugins and integrate them with Pulsar. And then sort of at the end, I want to show you how all of this can fit together within Kubernetes. And then the last few minutes, I'd like to leave, if we have time, for a quick demo to show you how all of this works. So what is Vault? This is a quote from the Hashicorp website. Vault is essentially a tool to manage and store sensitive data and provide fine-grained access control. Sensitive data can be anything from passwords, certificates, API keys, essentially secrets. It can also be something like a credit card number or a social security number. So besides secret management, Vault provides, I would say, three main features. Number one is the secret management. It provides a central store to store your secrets, keep them encrypted, and provide fine-grained access control. The other thing that it provides is it integrates with multiple different known identity providers and exposes them through a unified ACL. And so some of those providers are like GitHub, Okta, LDAP, AWS, GCP. And then finally, it also has this data encryption tool that provides key management to help simplify encrypting data in transit as well as at rest. So why would a organization or a company use Vault? I think as you're writing an application or developing something, at some point you're going to need secrets to reach out to something, whether that's a token to connect to a service, or a username and password to connect to a database. Real applications use secrets and sensitive data while they're running. Vault provides a single area or a single service for your applications to store and manage all of this information. It's also open source. It's cloud friendly. It provides audit tracking, so you know who is accessing which tokens and which secrets. And one very nice feature is it provides revocable tokens and features. So let's say I'm writing an application and I have my token, I accidentally check it into the code, I can very easily then revoke that token. So what makes Vault a good fit for Pulsar? I would say overall token management is something that is difficult, and it's kind of a pain, and Vault kind of solves that issue. It provides a way for you to manage your tokens, to generate new tokens, to renew tokens, revoke tokens. It also provides a way to store your secrets for functions and connectors. So if I'm writing a connector to I'm writing my data out to S3 with an S3 connector. I need to get my AWS credentials. Vault provides a way for me to securely get those credentials into the instance while it's running. And also, I'm able to, Vault is able to authenticate against many different backends. So, LDAP, Okta, Kubernetes, AWS, and GitHub. Now I'd like to generally go over the Pulsar security model as it is today. As you can see, when you deploy a Pulsar cluster with the defaults, there is no security, which is not a very good way to run a Pulsar cluster in production. Any client that can connect to the cluster has the ability to consume and produce data to any topic. It can modify any resource, delete any resource like a tenant, namespace, topic, or function. There's no auditing of any action, so I don't know which client is doing which action. And also, if I want to put secrets into my functions or connectors, the default way is you put them into the function config, which then are those printed to the broker log in plain text, which is not very secure. So Pulsar provides security at sort of 4 different levels. It has, you're able to use TLS for encryption of the traffic, connecting to the brokers, connecting to the bookies, connecting to Zookeeper, all of those types of things. It also has an authentication and authorization model. And then it also, at the end, it has, separate from TLS, it has a mechanism to provide data encryption between producers and consumers. So the Pulsar authentication model, it's a plugin based system. Its role is to essentially identify the role of the client, and then that role is used by the authorization system to grant access to resources within Pulsar. Pulsar ships with a few built-in ones. The Pulsar authorization system is also a plugin based system. This takes the client identity or client role that was determined from the authentication plugin and then decides whether that client is able to perform the operation it's requesting. The built-in plugin is a role-based system backed by Zookeeper. There are sort of 3 levels of roles. There's the super users. Those are allowed to do any operation across the cluster. And then there's tenant admins that can perform sort of admin operations within a tenant scope. And then you have the actions at the bottom that are usually assigned on a per namespace or per topic level, which allow clients to produce, consume, or deploy functions. Now I'd like to walk through how we could integrate Vault within Pulsar by kind of going through how you develop a custom authorization plugin. Before that, I'd kind of like to go over some best practices of building plugins, and all of these are the result of mistakes I've made in the past or issues that I've run into. One, generally, as a plugin writer or a library writer, you should try to minimize your third-party dependencies as much as possible, especially if you're writing a function plugin that's going to run with user code, so you don't provide clashes when the code at runtime. Also, if you're writing a plugin that's running on the broker or the function workers, and you need to make any type of remote requests to go out to a service, a database, anything like that, make sure you have your own threads or executors to do that work, so you're not interfering with the main Pulsar IO threads. And then, again, if you're making any type of remote request to get some type of data from a remote service, you should cache those responses for some period of time. Another good practice is to randomize the interval at which you cache them, so everything doesn't expire at once and you have to sort of, so then all the clients then end up hitting the server again. So to implement this Vault authentication provider, here's kind of the shell of what the code would look like. There's an authentication provider interface within the Pulsar code base. To implement your own, you would implement this interface. And I've sort of highlighted the main method that you need to implement, which is the authentication method, authenticate method. The authenticate method passes data in from the client, and then the job of this method is to take that data and then validate and identify the client and return a role. The role, which you can see as a string, that role is then used by the authorization provider to determine whether the client has access or the privilege to perform the operation. So once I've built my custom Vault plugin, I need to configure the broker to use that plugin. There's a section in the broker conf called authentication, and there's a section which is an authentication provider that can take one or many providers. In this example, we're just going to use one. We're just going to use the Vault provider. So here's sort of a diagram how everything works together. As you can see, you have a client, which would have a Vault token that would make a request to the broker. The authentication service of the broker would then call into the plugin with the authentication information, which would essentially be the Vault token. The plugin would then go out to Vault and verify the token, as well as get information on the token to determine the role of the client. The plugin would then return that role to the authentication service. The authentication service, it's not in here, but then that would call into the authorization service and say, does this client have permission to, for example, view stats? If the, and then after that's done, it will return the response to the client. So now that we've walked through developing a authentication plugin, I'd like to talk about developing function plugins. So I'm going to go over 4 function plugins. 2 of them are applicable to all runtimes, and these are secret plugins. These are essentially plugins that allow function instances to read secrets and get access to credentials. The other 2 plugins are Kubernetes specific and are only applied to if you're using the Kubernetes runtime. So Pulsar Functions has these 2 secret plugins. One is a secret provider. This actually runs in the instance, and it provides a way to read secrets through the function context API. The second one, hang on, I got a question. I don't think I can answer the question unless I exit out of the PowerPoint. Should I answer questions now, or should I wait until the end?
It's up to you. Do you want me to read it to you? Is that the problem?
Oh, yeah, I guess I can read it out. Yeah. And then do it. Yes. So the question is the Vault plugin code available somewhere? I was looking at writing the same thing. The answer to that is yes. We'll show you at the end. There's a GitHub repo that has sort of the basic working implementation of a Vault plugin for authentication, as well as to do secrets. So thank you for the question. So the second plugin that you can use is this is a secret configurator. This actually runs on the broker or the worker. And what the secret configurator does is it tells the instance which secret provider to use, as well as provide the configuration for the secrets provider. So here's some example code of how I would use a secret provider within my function. It's highlighted below. up above is the interface that I would implement to provide a secrets provider to a Java instance. This next one is the interface for the secrets provider configurator. You can see there's a lot more methods. I've highlighted the 2 methods below. These are the methods that are responsible for creating the secrets provider that the function instance will use, as well as the configuration that will be sent to that secrets provider. So how do you configure your function workers to use secrets? So there's a couple different configurations. First, you would configure your function worker to tell it which secret configurator to use. You can see here I'm giving it the Vault secret provider configuration, and then below is essentially a map of strings, which is data that I can pass then to the secrets provider. For example, I'm passing the path of where the secret provider can find the Vault token, as well as the address of the Vault server of where the provider needs to go out to read the secrets. So a little more detail on the Vault secret provider. The 2 methods that were highlighted below. So based on the function details, if I have any secrets for this function, I'm going to check the runtime, whether it's Java or Python, and then I'm going to return the appropriate implementation for the secret provider that the instance will use to read secrets. And then below, it's the same as the config before. That's going to generate a map of the Vault address as well as the Vault token, so the secret provider knows where to connect to the Vault server as well as where to read the token. So here's kind of how all of this sort of works together with this secret plugin. I've deployed my Java function. I want to read a secret called password. I use the context from the function API, get secret. That calls into my secrets provider plugin. That plugin then will go out to Vault and try to read the secret. Vault will return a response. So I have another question real quick. The question is, how do you inject your auth code jar files into the Pulsar instance? And in a few slides, I will get to that. I'll show you like how you can package your custom plugins into your Pulsar distributions. So yeah, thank you for the question. So here's the user code. So I get the secrets provider will then get the result from Vault. It'll do the parsing, and then it will return the value to the user. Now I want to talk about the other 2 plugins, function plugins that are only related to Kubernetes. So these are only relevant if you're running functions in the Kubernetes runtime. So there are two sort of main plugins here. The first one is a Kubernetes manifest customizer. This essentially allows you to do any modification to the function spec before it gets deployed to the Kubernetes API server. The second one is a function auth provider. And this essentially determines the auth parameters that the function instances will use to read their credentials to connect to Pulsar. So this is the Kubernetes manifest customizer interface that you would implement to do your own. As you can see, you're basically just passed in the function details and the stateful set or the service, and you're essentially at that point, you can do any sort of modifications that you want to that before it gets deployed. The next one is the Kubernetes auth function provider. it has a few more methods, and I highlighted this section below because I made a lot of mistakes while I was sort of implementing this. Um, the configure authentication config, that method is used to configure the authentication params that the Pulsar client in the instance will use to get its credentials to connect to Pulsar. And you can see there's a function data optional there. That optional actually comes from the cached auth data and the update auth data. So those methods will get called, and you need to pass back something, some type of function auth data for the configure authentication config to get called. So this is how I can run how we can now run the function instances with these Kubernetes plugins. So you'll notice now is I no longer have to go to Vault. So with Kubernetes and Vault, I can use this integration where Vault has this webhook where anytime I deploy a function, I can inject a Vault agent that runs with the pod. And what that Vault agent will do is it can go out, it will use the service account associated with the pod to go authenticate with Vault, get a Vault token, write that to a shared volume, and it'll also go out and it can also go out and fetch the secrets to Vault for me. So this drastically simplifies the implementation for a secrets provider plugin. Now all you have to do is read the secrets from files on disk. The Vault, another great thing about this Vault agent is it manages the refreshing of the tokens and the refreshing of the secrets automatically for you. So this is kind of related to the question. So now that I've built all of these different types of plugins, how do I package them? Where do I put them in my Pulsar distribution for use? So any type of plugin that runs with the broker or function worker, so that would be the authentication, the Kubernetes plugins, and the secret configurator. You can usually just dump those in the pulsar/lib directory, and whenever the broker or worker starts up, those will automatically get added to the class path. For functions, under the instance directory, there's also a directory called deps, which is empty. And by default, you can add custom plugins there that will get loaded at runtime. So for example, you can either put, I have the Java one here, but you could also put a Python one in there, and then that will get added to the runtime when the Python, that will get imported when the Python function starts up. So now I'd like to go through how does all of this fit together. So you have Kubernetes, Pulsar, and Vault. So how can I deploy a Pulsar cluster on Kubernetes and leverage Vault to secure my cluster? So here would be, I would say, a typical recommended way to deploy your Pulsar cluster if you're using functions in a Kubernetes cluster. I would definitely isolate, if I'm running functions, since it's running user code, I would isolate that to its own namespace from where the Pulsar cluster is running. I would also add an extra layer of security, such as just some network policies to allow the functions maybe to only be able to contact brokers. And then, if I have to run Vault within Kubernetes, I would definitely run it in a separate namespace. And I think that's sort of best practice, is to try to isolate your workloads between namespaces. So now that we've deployed Pulsar in Kubernetes with Vault, here's sort of a drill down view into the into one of the Pulsar pods. So as you can see, with Vault running, we have this Vault agent injector webhook running. So whenever a pod that gets annotated with certain annotations, that webhook from Vault will get invoked, and then Vault will essentially inject a Vault agent sidecar into the pod. What that agent will do is it will use the service account JWT token in the pod. It will use that token to go out and authenticate with Vault. Once it's authenticated with Vault, it will then download a Vault token and write it to a shared volume to a known place where the Pulsar process can then read that. One nice thing about this is, the Vault agent and manages refreshing of the token and all of those things. It will also manage, as we'll see later on, is you can add annotations to download secrets. So not only can it get you a Vault token, it can also get Vault secrets for you and write them to a shared volume. And it manages all. What makes it very nice is it manages all of the caching and refreshing, so you don't have to worry about that. So this is a example of how I would configure my function to get secrets. I highlighted the section below. So this is actually a section you can add to your if it's enabled. This is how you would add secrets to your functions. So basically, there's a secret section. That secret section, if I go down to the password and username, those are the names of how I would access the secret in the function API. So a few slides back, there was a call where it was context get secret and it said username. This is essentially it's calling into that. And these highlighted area, these are used by the Kubernetes customizer to inject the annotation, to set the annotations on the pod for the function, as well as there's an option to set a specific service account. So here's an example of the annotations that get injected into the pod by the customizer. As you can see, I'm telling I'm using the service account as the role to authenticate with Vault, as well as I'm providing information of which secret I want to read and how I want that secret written out to disk. So I think I'd like to spend the next few minutes of going over a quick demo and kind of showing you how all of this works together sort of in a real environment. Okay, so I have a Kubernetes clusters up, and I have one function running right now. So you can see here, I essentially have a function that I can show you the code quickly. It's essentially a secret printer. Basically, all it does is it reads out the secrets that I want to get and just logs it to the screen. So if I tail the logs of these, I can actually trigger the function and it will then print out the secrets. Kind of copied out my commands to Okay, so it took a little while, but as you can see, I was able to read the username secret as well as the password secret, and then I just printed them out. So I'd like to try the next few minutes, if I can get through. I'd like to try maybe a little more advanced demo, kind of show you how you can set up the secret in Vault, and then sort of deploy the whole thing. Okay, so first I'm going to create a service account for my new function. Next, I'm going to write out a new secret that my function is going to consume. So I'll go back to the Vault pod. So I added my secret. Next, I'm going to define a policy that allows me to read that secret. Next, I'm going to configure Vault to authenticate that service account and give it access to read that secret. Now I need to grant permission to that specific role or that service account within Pulsar so it can deploy, so it can download the function as well as produce and consume to the topic. Now I'm going to create the function. So hopefully it deployed. Okay, we can see the new one we just deployed right here. So now I'm going to trigger that new function to print out the secret that we just created. Wrong Windows. Oh, but if I scroll back up, you can see it was able to read that new secret that we just created in Vault. So it's kind of a quick demo of how you would set up a service account, create a secret in Vault, give that service account access to that secret within Vault, and then how you can deploy a function to then read that secret. I can quickly show you here's the configuration I use. So see, this is the secret I created in Vault at that path. This is the key that I want to read from that secret. And this is the service account I want to use to attach to the function so I'm able to read the secret. Okay, so that was a quick demo. Some future enhancements that I think could be beneficial or to integrate with Vault, or I've sort of looked at, is using Vault for all the certificate management within Pulsar. So to generate all the TLS certificates, to communicate between all the pods, so the zookeeper, brokers, bookies, as well as the functions. Also looking at how Pulsar, like a custom Vault authorization plugin, which could make something I've looked at, as well as using Vault for data encryption. Here are some resources that are worth checking out about sort of an overview on Pulsar security, as well as Vault, and sort of how Vault has these very nice tools to integrate within Kubernetes. So now I'd like to open it up for questions. Anonymous question, can I share the slide deck? Yes, I can share the slide deck after the presentation.
I have one that came in.
Yes.
What are some best practices for running Pulsar in Kubernetes?
Yep. Yeah, so that's a good question. I think some of the best practices are isolating things, especially if you're running functions. So you'd want to run your sort of core Pulsar components, the brokers, bookies, and zookeeper in its own namespace, and then also set up network policies to only allow, I would say, access to things that need access to. And, in most cases, most things only need to contact the broker. And then if you're running any sort of functions and you're running them in the same cluster, again, make sure to run those in a separate namespace from where you're running your core Pulsar components, as well as adding, network policies to sort of restrict what they can do.
Great, and it looks like we have another one that just came in through the Q&A, a couple more in the Q&A.
Yeah, any thoughts on the approach to implementing end-to-end encryption? Yeah, I mean, I have some thoughts. I've sort of looked at it. The great thing I like about Vault and sort of the agent is it provides this sort of easy management to dynamically generate certificates and put them on the pod, and also refresh them. I think it would be something to explore. Okay, there's another question. Is there a link to the code demo? Yeah, I'm going to go just to the next slide so people can see this question one. So yeah, below here's a link to the code. That was one of the questions. That's the correct repo that he was asking. So another question is, can Vault be used to manage TLS certs just as Pulsar plugin isn't built yet, or just is not possible? Yes, Vault can be used to could be used or configured to manage TLS certs. It also there's a popular cert management program or application in Kubernetes. It's a cert manager, and they also provide a way to plug in to Vault to help manage TLS certificates. Again, one of the things I like about Vault and is they've done a very good job of integrating with Kubernetes, as well as it's one central place that you can use to store your certificates, your tokens, as well as your secrets.
Okay, great. Well, it looks like we are right on time here, wrapping up for the day. Thank you so much, Chris, and everyone that's attended this session. You can see his Twitter and his GitHub right there. So 2 great places to connect with any follow-up questions.
Yeah, feel free to reach out to me or find me on social media. And thank you, everyone.